Good morning, evening, or afternoon, whenever you're watching this. So we are in week 4 of this geometry read class, and I just want to say that last week was difficult, and I'm glad you got through it. However, this time we're going to switch gears. We're no longer doing some of the trigonometry stuff. We're actually moving on to some of the volume stuff, and given the fact that there's only 5 weeks, I had to cut out a lot of the stuff that we're doing. So if some of this seems rushed or you're just like, this is completely different from what we've been doing, that's understandable. Just know that this is pretty much what we're supposed to be doing. Okay. Okay. So why don't we just start with what the vocabulary is? If you don't have it, please copy all this down. Right. We are. Give me 1 second. Sorry about that. Okay. So now go ahead and write this down if you haven't already. The right prism is what we're going to be dealing with. We're going to be dealing with 3D shapes and finding the volumes of them. Right now, we're just going to be focusing on two things: rectangular prisms and cylinders. So as you can see, the definition for a right prism is confusing. It pretty much just means a box. It's a box. We're going to be dealing with the box. Sometimes the box will have rectangular sides to it, and that is what we call a rectangular prism, as you can see below here. Right, so just give me 1 second. Maybe. Uh, okay. Right. So with that said, as you can see here, it's one of these, but sometimes we also have what we call a square prism, or just, again, I can't stress this enough. It's basically just a box, the kind that you get things delivered to you. That's what we're going to be dealing with here. I want you to just picture a box every single time I use these terms. However, we have to use these terms because when we don't know what the shape is, or when we need a better way of describing it, we're going to use this definition. Um, just know that if all the dimensions of the box happen to be the same, then it's a square one. And there's a completely separate formula for that that makes it a little easier. But really, you can just get away with using the rectangular prism. I didn't include the formulas on this page. We're going to do the formulas on the next page. I'm just kind of giving you a general introduction to what we're dealing with here. The cylinder, right? It looks like this. It has two circles and it's combined by a height, right? Just like a rectangular prism has a square or a rectangle, and then it has a height. So I don't know if you guys are noticing a pattern here. And an oblique shape is basically either of those two, but if they happen to have been slanted, and again, they have both a height, if you notice here, but they also have what we call a slanted height, right? And no, they're not the same thing, because what you'll see when you see the formula is that a lot of the times the height in and of itself is what we're supposed to be using. However, if you use the slanted height, it ends up throwing off your numbers, and it makes it seem as if your shape has more volume than it actually has. And then that could throw off a lot of calculations, and that can be bad, right? So just keep in mind, these are the three different ones that we're going to be focusing on. I'm going to show you how to find the volume of each of these things, and you're going to have to know how to use the formula forwards and backwards, meaning that if you are given all the dimensions of a rectangular prism, you should be able to tell me what the volume is. If I give you the volume in two other dimensions, like length and width, you should be able to figure out how to give me the height. Same thing for the cylinder. If I give you 2 out of the 3 pieces of information, doesn't matter which 2 I give you, you should be able to plug them into the formula and give me the last piece of missing information. However, depending on what information I give you, the problem can be solved in an easy way or in a slightly harder way. And I'll go into that in a second. For now, just take a look at this problem. Find the volume of a three-dimensional shape. Now, notice I just said three-dimensional shape. We're dealing with the reason why I'm saying 3D is because 3D represents the world in which we live in right now, where you're at, right? Everything in this world that you can see, feel, and touch has 3 dimensions to it. And by 3 dimensions, I just mean it has let's undo that. It has a length. It has a width. And whatever object you're looking at, it also has a height. When all three of those dimensions are combined, they give you volume, right? The amount of space an object is taking up within our world that we live in. Two-dimensional shapes are just regular squares, regular circles, right? They have two out of these things, right? They have a length and width usually. They have two dimensions, but they all do not have depth to them. A two-dimensional object does not have depth, which means it does not have height, which means that you can draw something on a paper and the paper is flat, and that's two-dimensional. But to make an object three-dimensional, you need to give it height. So height is actually really important to a 3D shape. In this case, we happen to know what all of them are. And again, you should know where everything is. For example, length represents, in case you didn't know, from left, usually to right. Okay. Width, there's some debate as to whether length and width can be interchangeable. And I suppose they can be, depending on which way you're looking at the shape. But I tend to think of width as the one that's sort of diagonal, right? That 7, right, represents the width in this case. And again, you can argue that length and width can be replaced. It honestly doesn't matter. It's all a matter of perspective, because if you're just looking at a regular square on a drawing, then length and width, you could argue that it's either one, either or, right? You just have to decide which one it is. Either way, right? If you don't know, and you're given like a word problem and you have to draw out a shape, I would draw it like this, right? The height, of course, represents up and down. Okay, that's usually what I use to like anchor myself to this. And by the way, if you don't know how to draw a cube, essentially, or a rectangular prism, I'm not the best at drawing, so I'm just gonna show you really fast. I usually just draw a square or something, and I draw another one a little bit diagonal to it, and then I just basically connect all the points, and then I have one of those, right? So that's basically that's how I draw it. My drawings are terrible, but I know how to do that. So, anyways, back to how to actually solve this, right? If I wanted to find out the volume of the shape, I have to start with my formula, and my formula is right here. Volume is equal to length times width times height. That's step 1. That is my formula. Step 2 is to essentially substitute. I know I have multiply right here for step 2. It's because I kind of skipped the gun. This one's really simple. I just replaced all the letters with the values that I have. I know what my length is, it's 5. I know what my width is, it's 7. And I know what my height is, it's 4. So 5 times 7 times 4, if we were to multiply them all out, I just get 140. Now notice this, I want to point this out. I have meters cubed, right? That's not part of the problem. That, you can think of the meters cubed as a label. Remember how I said that this was a 3-dimensional object, right? Well, in order for me to know that this is a volume problem, and a really like easy way to know is if the problem is labeling things in squares or cubes. For example, if I'm given this 140 meters squared, this is referring to area because they're saying that there's 2 dimensions, right? I'm just dealing with length and width. Usually this would be like, okay, a property, right? When you're buying a house, they say 140 square feet. That square feet is the 2 dimensions that I'm talking about. Let's say 140 feet squared. That's the same thing. Squared feet, feet squared, it's the exact same thing. In this case, I had meters. It's the metric system. It's the same thing, just a different way of measuring. However, here I have m to the 3rd, which is suggesting that whatever house I have is 140 meters cubed. That means I'm talking about the entire area the entire space that that house occupies, including its height, right? So that house is a really big house, if that is the case. It's 140 meters cubed. That's all the area, right? If I were to make boxes of rectangular cubes that are 1 meter by 1 meter by 1 meter, and I were to fill up the house and I were to stack them until they, it fills up the inside of the house, I could fill it with 140 of these 1 by 1 by 1 meter blocks, essentially. That's what it is. I would prefer that you do put the meter cubed at the end of your answers, just because it is a label and just because it does let me know that you understand that this is a 3-dimensional answer, not a 2-dimensional one. We're not going to be dealing with 2-dimensional ones um, until we probably get to surface area. I'm still debating whether we're going to do that or not. So anyways, right, that is our answer, right? Long story short, that is how we find the volume of a rectangular prism. All right, why don't we move on? Right? Remember how I said that you had to know how to do this forwards and backwards? Well, what if you had a problem that was like, hey, I know that the volume of this place or whatever is 140 meters cubed. I know that the width, for whatever reason, is 7 meters. Okay, that's confusing. Hold on. There you go. And my height is 4. I have this, and they're saying, but I need to know the length, right? So let's read what the problem says. Find the missing length of a 3-dimensional object when its volume is 140 meters cubed, its width is 7 meters, and its height is 4. I know I just put 4, but I was supposed to put 4 meters, right? What are you going to do? Well, step 1 is always the formula. Even though I'm given my volume, that's not what they're asking. The problem is asking, hey, can you find the missing length, right? In other words, I want to know the length. What's L? I already know what the volume is. This is still considered a volume problem because you're going to be using the volume formula, but you're not looking for volume. So we start here, and if you notice, I just plugged in 140 instead of V. I don't know what L is, so I just left it as L. I plugged in, right? 7 for W, and I plugged in 4 for H. All right, that's substitution. Then we have 7 times 4, right? We're just multiplying here. So I just multiplied it, and I ended up getting with, I just reduced this. I brought it down. 140 is equal to length times 28. 7 times 4 is 28. Okay, so this should look familiar to you guys because you guys have been doing this for the last 3 weeks. But when we get to this point, we need to do what's called isolate the variable. As such, isolate the variable, which means that we have to do the opposite of what's currently happening. Now, the variable here in this case is L. So L times 28, the opposite of multiplication is division, which is why I have a line. I have 28 underneath there. But if I'm going to divide 28 by 28 here, I have to do it by the other side as well. 140 also has to be divided by 28, which means that my, that doesn't look right. Let me just double check that. 140 divided by 28 and see what I get. I have 5 there, but I'm just double checking on my calculator. 140 divided by 5, oops, divided by 28 is 5. Yes, okay. That just didn't look right, but it is correct. And that's how I would find my missing length, okay? There's not much else to say about this. I guess I will take some time to, do you remember when I used the word oblique earlier? And then I showed you, let's see. However, this shape, right? Let's pretend that it was diagonal, right? The best way I can describe an oblique shape is that it's kind of curved, right? This is still normal-ish, right? Hold on. This is like the normal shape, However, an oblique shape would be kind of like this. It would be like, do you guys see the difference there? Like, what's the biggest difference? It might be better if we length, width, height, length, width, and height. Okay, so right away, basically the difference between I guess I did that wrong, but the biggest difference is that one is slanted. Oblique suggests that a shape is slanted and that it has a slanted height, and you don't want to use a slanted height, right? The height here is slanted, it's to the side, right? And because it's to the side, it's a little longer than it should be. Your height has to be straight like this. So the slanted height might be like 7 or something, versus the actual height should actually be 5, right? Because when you compare those two lines, like the slanted height and the other one, they're actually, one has to be longer, which is why whenever you're dealing with an oblique of whatever, you need to make sure you use the correct height. Okay. Um, I'm gonna try to avoid giving you these problems, but when I do give them to you, it'll be very obvious that the shape is like to the side, and there'll be multiple heights. So you'll have two options for heights, and you need to pick the one that's correct. Okay. Usually, if you have two options on heights, the smaller one is probably the correct one. Okay. So moving on to cylinders, right? So we have a cylinder right here. Find the volume of this right cylinder. First thing we need to do is we need to determine a couple things. Now, the formula for the volume of a cylinder is pi times radius squared times the height. Now, I want to say something about this. This is actually the area of a circle. It's a formula for the area of a circle. But since we're multiplying it by the three-dimensional shape object's height, it suddenly becomes three-dimensional and it becomes our volume formula. So this formula actually has a separate formula inside of it. And you'll see that why that matters later. For now, we know what pi is, right? That's a variable that's 3.14, and it kind of goes on for a really long time. For our purposes, whenever we try to find the volume and we have to use pi, you can either use the pi button on one of your calculators, or you can use the abbreviated 3.14 value, okay? I prefer if you just use the 3.14 value because it cuts down on the amount of decimals and it kind of rounds for you. So yeah, use that instead. That's going to be a constant. Every time you see that symbol, 3.14. Radius is going to change with every problem, and so is height. However, if you notice, there's a square here, right? So that means that whatever the radius is, we're going to have to multiply it by itself. Okay, I just want to point that out about the formula. Okay, cool. So this is a little more complicated than the last one, but we can do this. Whenever we are trying to do this, we're always going to start with the formula, right? And I have the steps down here, but the first thing you should always do is identify what the height is. Now, in this case, if you notice, I have the height. I'm actually pointing at it. It's 10. They straight up give it to us in this case. And then there's the radius. The radius in this case is the only other number given to you, and that's 3. However, you need to understand what the radius is. The radius is the center of the circle, is the line from the center of the circle to any point in the circle, right? You can only use the radius for this volume. If you are given something called the diameter, right? You might be thinking, well, that looks exactly the same, except it's not. The line I just drew is from one end of the circle to the other, and it crosses that point in the middle. That's what we call our diameter. And our diameter is always 2 times that of our radius. So if you're given the diameter, which you are going to be given the diameter, and you don't notice that it's the diameter, and you put the diameter instead of the radius, you're going to get the wrong answer. It's going to be too big. However, if you get the diameter and you recognize, oh, this is a diameter, I need to cut this in half before I do anything else, right? 6 divided by 2, 3. There, my radius is 3, right? So even if they didn't tell us that, you could figure it out if they told us what the diameter is. Okay, cool. Now that we know what this is, right? Now that we know what this is, and of course we know that pi is always going to be approximately 3.14. Let's go ahead and go here, plug everything into the second step right here. Volume is equal to 3.14 times 3 squared times 10. Now, in case you don't remember, 3 squared is the same as saying 3, not times 2, but times itself 2 times 3, which is why it's 9. 3 times 2 is 6. 3 squared is 9. There's a difference. Okay, ignore that. Now, from here, we have volume is equal to 3.149 times 9 times 10. I'm just going step by step so you know. And then 9 times 10 is just 90. Volume is equal to 3.14 times 90, right? So all I've been doing is just simplifying. That's it. And then, of course, I put it into my calculator. 90 times 3.14 gives me 282.6 meters cubed. That is my volume. I'm done. That's it. Okay. Is it though? Because that's the easy problem. The harder problem would be what if they gave you, look inside here, right? I didn't feel like drawing another cylinder because it was very difficult to draw that one. However, I'm going to change the information. I'm going to give you the volume instead, and I'm going to ask that you figure out what the radius is. And this isn't going to be like as easy as the last problem, okay? We are going to have to, we're going to have to take assessment of what we know. We know 2 out of the 3 things, so we're good, right? We can figure this out. Yes, it's 100% possible to figure it out. However, like as usual, we're going to start off with our formula. Oops, let's go back there, undo. Okay, R is, right, we don't know what it is. That's why I did that, okay. Our height is 10. And let's go ahead and erase the V here because our volume happens to be 314. That is intentional, by the way, to make this a little easier for you. Okay, so 314 is equal to 3.14 times R squared times 10. Okay, so what do we do now? I'm going to leave the R squared alone, right? I'm going to bring this down, 3.14, and I'm going to multiply 10 times the 3.14 because all these numbers are basically multiplying. They have, like, R has its own thing going on, but it's essentially whatever R squared is, it's essentially going to multiply by the others. So I'm going to use a really old property that says that if I'm multiplying all the numbers, I can switch them around the order in which they're being multiplied, and I'm still going to get the same thing. So I'm going to multiply 3.14 times 10, which gives me 31.4 times R squared, right? So at this point, right, I have a variable and a number in front of the variable, multiplying it by it. So I'm going to have to divide by 31.4, divide by 31.4, right? So if you're keeping up on your own calculator, right, I want you to go ahead and do this. Go ahead and put, let's see, let's get rid of this. 314 divided by 31.4. And what you should have gotten is 10, just 10 equals R squared. Cool, we know what R is, we're good, right? No, because we have R squared, and that is a problem. Whenever you run into like an R squared is equal to something, remember, we're gonna have to get rid of that square. We just want what regular R is, right? The opposite of a square is a square root, so that this can cancel out with this. Now we need to find out what the square root of 10 is, right? So I'm gonna, if you're doing this on a calculator, if you're doing this on a regular calculator, like an Android calculator, you have to put the square root symbol first. So you're gonna have to do square root, and then it's going to be, you're gonna have to plug in the number after, right? If you're doing this on an Apple, right, then you need to put the number 10 first and then look for the symbol that looks like that, okay? Look for that symbol. And then you're gonna have to press it and it'll give you the same answer. Anyways, this will be 3.16, and then there's like a 2 after. I'm just gonna round down. 3.16 meters, but notice there's no cube because I wasn't looking for the volume. The volume is three-dimensional. The height is not. And if you're correctly asking me, well, you put meter square on height above there, that was a mistake. Thank you for pointing that out. I just realized that. It's not supposed to have anything on it. Regular numbers, regular dimensions don't, I guess they do have a dimension. It's 1, right? But we don't ever put that there. But if it helps make sense, a regular dimension would be 1 dimensions. 2 dimensions combined would be 2 dimensions, and 3 dimensions combined is, well, 3 dimensions. So this is just 3.16 meters. There's no square, there's no cubed. I guess there's a 1 if you want to put 1 in, but we don't really need it. That's my answer right there. Okay, by the way, if you are looking for height instead of R, right? Would that have changed the way you solve this? Yes, but not that much. That would have been easier because if we would have known what R is, we wouldn't have had to square root at the end. Right? There would have been no square rooting because I could have just, if I knew that this was 3.16, I could have put 3.16 in R instead, square that, and I would have had whatever that is squared times 3.14, and then I would have divided by whatever that is, and you would have solved it the way you solved the other one. So if you're having trouble with this, please let me know, all right? But we have one more thing, all right? So one more thing before I let you guys go here. Composite shapes are, basically what a composite shape is, it's multiple three-dimensional objects put together, usually on top of each other or connected to each other by some way, right? In this case, we have this monstrosity over here, which is basically just a box, and there's like a cylinder on top of it. So I guess in the real world, this would be the equivalent of like a really small box with like a soda can on top of it. And for some reason, I wanted to know the volume, how much space is inside of both of these objects combined, right? That is what we call a composite problem. And yes, you are going to have to do this. Now, the first phase of a composite problem is there is no one formula that will give you the shape or the volume of a composite figure because there is just no way to know. There's just no way to know. There's an infinite amount of shapes that can be combined, and there is not one single formula that will give you the correct answer every single time. So how do we solve a composite shape problem is you need to look at that monstrosity I've created over there, and you need to break it down into shapes that you recognize. So remember, the can on top, the soda can on top, right? That's a cylinder. You know the formula for a cylinder. And the box on the bottom is essentially a rectangular prism. And you know the volume, the formula for the volume of a rectangular prism. So you're gonna have to make a T-chart the way I've done here and do each formula, right? What if you happen to have 2 boxes on top of each other with one box just being slightly smaller? You're gonna still have to do the T-chart, but instead of it being rectangular prism and cylinder, it'll be rectangular prism and rectangular prism. And yes, I did miss a couple of misspellings in here. It is hot and the temperature is making me really irritable. So forgive me for that. However, let's just pretend I spelled that correctly. Let's move on to rectangular prism right here, okay? We're gonna solve this the way I normally do. Now, if you notice here, I have VP, right? The P is just prism. I'm just labeling them because of what I'm gonna label down here, right? But I'm gonna solve this the way I normally would. The first thing I have to do is I have to take stock of what my length, width, and height is. My length is left and right. It's clearly gonna be 4. My width is gonna be diagonal, which is 8, and my height, which is gonna be 5. Now, I hear you saying, well, if we're going to multiply them anyways, does it really matter which one I label as which one? Like, are you going to take points off if I put 8 first instead of 4? Well, remember, no, not really. But remember, it's best that you get into a habit of labeling because it does matter a lot if we're doing surface area, which we're not going to do in this video. But surface area requires that you are able to do labeling correctly. So you might as well practice now. So anyways, right? If my length is 4, my width is 8, and my height is 3, I'm ignoring the other numbers from the cylinder for now, and I'm just focusing on those. 4 times 8 times 3, 8 times 3 is 24, 24 times 4 is 96. Okay, cool, check that off. Now move on to my cylinder. Okay, now I'm gonna ignore all the rectangular prism measurements, and I'm gonna just focus on the height of the cylinder, right? My height is 5, and my radius happens to be 2 here, right? I didn't have to do anything crazy. But if they had told me 4 and they had given me a line that says that tells me it's my diameter, I would have had to divide my diameter. I'll go into that a little bit more about that later, but for now, volume of the cylinder is equal to pi r squared times h. Volume of the cylinder is equal to 3.14 times 2 squared times 5. This is why I say you have to ignore the other one, because remember, my height for one of them is 3, but my height for my cylinder is 5. And I need to make sure I put the correct height. Because if I had put the wrong height, my entire problem gets wrong, which is why you need to label, right, which one it is. Hey, I spelled it right that time. Okay, so, right, so then I follow the steps like I've normally been doing, right? Volume of my cylinder, 3.14 times, and then 2 times 2, which is my square, not because there's a 2 on top, but it's squared and it just happens to be 2, right? So 2 times 2 is 4, 5 just came down, 4 times 5 is 20, which is why I have 20 times 3.14, which is why I have 62.8 centimeters cubed. Okay, now that I have my 2 answers, now that I know the individual volumes of the soda can and the box, all I have to do is add them. Because remember, one is on top of the other. So I'm basically just adding their volumes together. My volume of the rectangular prism plus the volume of my cylinder equals my composite volume, my volume of my composite shape. So that's 96 plus 62.8 equals 158.8 centimeters cubed. That is my answer. Cool, I'm done, right? Sort of. There's going to be another type of problem that you're going to encounter a lot, and that's 3D shapes inside of another 3D shape. In other words, let's take that example from earlier, right? I have a box and I have I don't know, soda can for some reason, right? However, let's pretend that this time I don't have a box. I have some kind of a wooden cube or something, right? And I drilled a hole right through it, a perfect cylindrical hole right in the middle of that block of wood or whatever, right? I don't know why I would have been compelled to do this, but I did it. And I ended up with this. I ended up essentially with what looks like a cylinder inside of a rectangular prism, right? And the key is inside, because what happens is if I ask you, hey, can you find the volume of this new of this wooden block that I completely just drilled a hole into, right? It's not going to be the same as this, right? I can't. I'm going to use the same process, right? I'm still going to find the volume of the prism. I'm still going to find the volume of the cylinder, but at the end, I'm going to make one small change to reflect reality. The reality is I drilled a hole through that block of wood, and it just happened to be cylindrical, meaning that it is missing. That hole implies that it is missing an entire cylindrical block, meaning the volume of whatever the cylinder is was just taken out of that block, of that rectangular prism, meaning I cannot add them together. I have to subtract. And that's literally the only change you're going to do. The volume of my prism, as you guys have seen, is 96. The volume of that cylinder doesn't actually exist anymore. It's not there. I took it out. I drilled it out because I needed a hole in a block of wood for some reason. It's 62.8. So 96 minus 62.8, right, is 33.2 centimeters, meaning that rectangular prism, after I removed a bunch of its volume, right, the volume left is naturally going to be smaller, right? And that's the distinction that you're going to have to do. These problems that you're going to be doing are not hard necessarily, like the math isn't going to be crazy, but you are going to have to look out for minor details. And speaking of minor details, right, segue into this, small notes about shapes. I remember how I said that there was this thing about circles, about radius and diameter. Well, I'm going to go into more detail about this because normally in a normal class, we would have gone over all of this in a separate unit. Because we're only doing 5 weeks, I'm just going to tack it on at the end of this and hope that you remember it. So right here, we have a radius, which is the center of a circle to any point on the circle. Diameter, length from one end of the circle to the other side of the circle. I have this formula here, D equals 2R, right? And I've said this before. If my diameter is 10, right, and I need the radius, I just divide the diameter by 2. Okay? That's all you're going to do. Right? I don't care what number is in there. If they give you the full diameter, right, that's from one end, that's this thing. This thing is the diameter. The half one is the radius. So if they give you the radius, you're good to go. Just plug it into your formula, you're fine. If they give you the diameter, cut it in half. All right? The reason for this is, as was stated earlier, the area of a circle can be found using the formula pi r squared. Right? And if we were to give that circle a height, it becomes cubed. It becomes volume. Okay, so that's about as far as we're going to get into this. Please, you know my email. Go to Google Classroom if you don't know it. Make sure that you guys let me know if you're having trouble. And good luck with the heat because it is hot. It physically hurts right now. All right, so with that said, good luck, and I'll see you.